All right. So it's crazy. We are just flying through the course, it seems. Um, you know, really down to the wire here on our last little bit. So anyways, don't have much left, which is really good. So this week what we're gonna go over is our we're going to go over some indexing and constraints. Last week, you should have learned about transactions, and due to the holidays, we didn't have a meeting. But transactions, just to do kind of like a real brief overview, I like to think of them as kind of like saving a video game. You save a place, you can do some work, and then you can either restore it. So a lot of times, really, before we do anything in the database, usually in production databases, I always kind of wrap my work in a transaction. Even if it's not production, you kind of get in this habit of doing it because you'll find that sometimes you can mess things up. And it's always good to kind of just be able to say, whoa, that didn't work out the way I wanted it to, and just kind of undo it. But anyways, yeah, we're going to jump into indexes and constraints. And this is one of those that I always really like to cover, because for me, this is like a prime example of how I feel like, I guess just to back up, I've always been fascinated with like motors and engineering and that kind of stuff, and even computers. Like to me, a solid state driver, like storing stuff digitally in like memory, makes way more sense than the old hard disks, the actual disks that would spin. Like still to this day, like hard drives and CDs are just like mind boggling to me. Physical medium, like the engineering to me, even though I know it's not true, the engineering seems to be way more precise at that level than it is nowadays. We have so much help and stuff that, I almost feel like, if they could have just skipped all the learning how to do it, they would actually agree that it's probably easier now, um, than it was. And like same thing with motors. So this to me is like another one of those examples where I love it because it's super. It's a great nod to just how ingenuity of humans, even before computers, has still turned out to be this like useful thing. And even with all this technology, it's still fundamentally at a base level doing the same things that humans did, just digitally in a faster way. Which I personally love. Like that whole concept to me is super intriguing, and I love it. So, anyways, a lot of this week we're actually going to be spending time talking, just conceptually and not even really showcasing some of the stuff. The exercises this week are really simple, but I really want to kind of talk through these indexes and constraints, conceptually. So, anyways, we're gonna kind of go back in time, and I don't know if anyone here in the meeting today is quite as old as I am. I barely remember these myself. Um, and maybe someone is as old, feel free to chime in, because I feel like it's older, but older colleges I still think kind of have these in some of the libraries. But so when we think of indexes, like, I always think back to index cards, and index cards, came from something very particular. So like, if we look at not ink, just want index systems. Um, let's look at library index system. So anyways, we've probably all like at least heard of these. And this is where, like I said, the index card kind of came to be. And sorry, whenever I do a Google image search, I always like to keep it off there until we can check. Yep, there it is. All right, so you can see here that this may be a familiar site, right? These little bins, and they used to have like shelves of these, and this is where the index card came from because it fit perfect in there. And believe it or not, it was used for indexing. And so before computers and, when you walked into a library, for us, it's easy now, to be able to search for a book on a computer and even find a physical asset. Or even more so, search on Google and find a plethora of an uncountable number of digital assets across an even larger space. But even back in the day, I remember my earliest memory of this is actually in elementary school. Walking into a library, and if you were looking for a particular book, you had to use an index system, or if you were looking for certain things. And so I remember as a young elementary student having to do like our first kind of nonfiction report. And so it's like, oh, I want to, do a report on like turtles, for example. So the way you organize a library, usually you can kind of pick and choose. Some of the libraries would probably do it by reading level in an elementary school, but some might also do it just by author. And they may have sections like, oh, you're in the nonfiction section, and then nonfiction section, and then we alphabetize by last name of the author. Similar, most of us have probably been in a Barnes and Noble, similar to that, right? And so so if you know the last name of the author you're looking for, it's great. But if you're looking for a title, even, it becomes more difficult. Like, let's say all is the title of the book, but not the author. Well, without an index, it would be impossible. And so, without checking each book one by one. And so you're going to start to see some of these concepts emerge that are the same. So same thing in a database, if nothing is indexed and we say, hey, I'm looking for this customer in this table, the only way that the computer really knows how to get there is to start with record number one and just go all the way through until it finds what it's looking for, because they're probably not in order, right? They could be in any given order. A lot of different things could be happening, because usually they're just put in the order that they're inserted, right? And so customers won't be in any particular order. And so what these index cards would do, like these bins like this, is, basically you could have a number of different bins, these little bins, and each one of them would do like a different index. And so let's say you alphabetize your library by last name. So someone comes in and they say, hey, I know the name of the book, I don't know the author, I want to read Words of Radiance, or The Way of Kings. I don't know who the author is, but I know the title of the book. The title of the book's called The Way of Kings. So what they would do is they'd come over to their bin that they have set up just for books of titles of books. And, each bin would have like a certain subset. Like, let's say each one of these bins is like letter A, B, or if there's tons of books, maybe it's like A through A M, and then the next bin's AM through this, so that way you can kind of like start to pick. So you find your bin, and you think about the difference there in speed. Oh, great. I'm glad to see you're reading Way of Kings. I love Brandon Sanderson, so I'll reference it whenever I can. But anyways, like in that scenario, let's say that there wasn't an index, the only way to find that book would be to go one by one. This is before the day of the internet and whatnot. And so we would just go one by one, and that's not, that would take forever. Versus this way, oh, I'm looking for it by the name of the book. I mean, think how much quicker that is. We still have to do a little bit of manual searching, but instead of looking through a million books, we end up looking through a smaller subset. And you'll notice even when we open this drawer, they're even partitioned within it. So that way the idea is that you want to narrow the scope as easily as possible down to exactly what you're looking for, to where maybe, hey, by the time I narrow this down, I only have to flip through 10 cards, right? And that's exactly how database indexes work, right? There's a couple different kinds, but that's the concept, is it tries to narrow down as best it can, so that instead of searching for going one by one through a million records, it can just pinpoint a smaller subset. So, a good example, like, think about the amount of data that comes with like Facebook, or, some of these larger platforms, or even, like Canvas, like something we use every day. Um, just an absurd amount of data. And a lot of this data would be completely, like, I guess a good example. In one job I worked, we were storing firewall hits. So it was for public school. And, as part of that, they had to keep their internet secure, keep it clean, make sure students weren't searching for things they shouldn't search for, those kinds of things. And as well as track what sites students were going to, so that they could proactively, keep everything safe and secure. And, that's a ton of data. You think about 800 students in a building that have devices all the time, with their phones, their school issued laptop, constantly hitting everything. And then to search through that was incredible. And even to search through one person's history. So, that's a great example. Okay. We have 800 students plus staff all generating traffic. And you can think about how quickly we generate traffic. Before we index this, and this is a great example, because a coworker of mine initially kind of set up the storage of this data. And when it came time to actually use it, he's like, whoa, like I actually can't do anything with this. The queries I tried running one query and it never finished. It ran for 24 hours and then it failed. And so I said, well, like, what are you indexing? And he's like, oh, I haven't built any indexes. And I said, well, we need to build some indexes. And so, like we built an index on the timestamp. We built an index on like the IP address, and the MAC address. So like we built these different indexes. We built an index on the domain name of the URL. So anyways, we could build these indexes so that way, whatever he was searching for, and this is where indexes kind of come into play. Whatever you put in the where clause, right? Whenever you're like filtering, looking for something particular, you want to index that. Now, whether you're doing like an analysis like this, or like actually looking for something, or whether you're building an app like Facebook, this is something you're going to want to think through. Like when I load up Facebook, it immediately needs to filter posts to fit my scope. Like if someone opens up my profile, it immediately needs to narrow, an uncountable number of posts down to one single user. And it does it that fast. It's super quick. And that's where these indexes come in. So they obviously have an index built on users and like profiles, as well as probably dates and a ton of other stuff, right? It makes it faster, because then what the database does, like if we go back to this example of the traffic, we built that index on the MAC address. So we could look up a student's MAC address and then say, hey, what traffic is this user generating? And we could put that in the where clause, and then basically just like it did with the user with the book title, instead of having to go one by one through every record in that table and say, is this one? No. Is this one? No. I mean, it's super slow. Instead, it can just say, hey, I know that this person is in this little subsection, and it can just pick those, grab them, and pull them out, and then we have them. The concept works the exact same. Now the question is why don't we index everything, right? If it makes it so much faster, why don't we index everything? Well, just like these filing cabinets, every time you index on a particular column, whether it's a book title, whether it's the date published, whether it's the topic, right? You're generating data on the data itself, right? So we have our library books all stacked up, but then we also have to build these cabinets and those take up space, they take up memory. And even though they make searching through the stuff faster, let's say we built an index on everything possible, the publisher, the title, the this, the that, everything. Eventually the library becomes so cluttered that it doesn't actually save you anything as far as speed goes, and the library's full. You don't even have room to put more books in it. And then on top of that, every time you get a new book, so this is an important part, every time we get a new book, keep in mind that you'd have to do all the work to catalog that book in every index that you did. So let's say you had it just on author, publisher, date published, and title. You're going to have to make 4 index cards for every book and go put that in the drawer, right? So every time, and the database is the same way. Anytime you add a new record to that table, it's got to do the work to kind of keep all this information indexed. And the more information that you're kind of doing, the less efficient the database becomes, just as if we were a normal person. Again, I love all the comparisons we can draw here. It really helps me conceptualize it. And so when we index our databases, we want to be smart about it, because we don't want to create extra pressure on the system, but we want it to work for us. So that's why when you hear about, you'll hear about database tuning, and that's like a whole specific subset of these database architect data design skills that are particularly focused just at the efforts in tuning SQL queries, tuning the queries themselves, but also the database. Like, hey, if we index this column, we can cut this time by X amount, which is really neat. So I'm going to pause right there before we jump into kind of some one, we'll talk about the unique type of indexes, and then we'll actually showcase how we can kind of measure the impact of these. Does anyone have any questions as far as everything making sense? I'm getting a thumbs up, so I'm going to take that. Perfect. All right, we'll move our library indexes over here to the side, and we'll jump right into this PowerPoint here real quick. All right. This is going to talk a lot about just kind of the code and everything. Let's talk about constraints though real quick. So we talked about indexes, which makes sense. But what we haven't talked about is constraints. And the reason these are kind of lumped together is because there's some indexes that create constraints. So a constraint is just like what it sounds like. It's a way we constrain our data, meaning we limit what people can do with it. So like a good example is, let's say that we have email addresses, and this is a great example. We have a customer and we have these email addresses. Well, for security reasons, you can imagine that it doesn't do anyone any good to let 2 people with the same email address be users, because so often we use email for authentication and password resets and all that kind of stuff. And so emails are a great example of when we would put what we call a unique index on a column. So if we put a unique index on email of the customer table, basically you'll see if we tried to insert it again, it'd say, hey, you can't do this because it already exists. So it's like a safeguard for our data. But what it does is it also indexes it, because if it's unique, the computer really likes things that are unique, because it means, hey, if I can find this, there's no more. You're right. So if I say, hey, I'm looking in the customer table for this email address, if there's a unique index on there, once it finds it, it can stop looking, because it knows that it's impossible for 2 emails of the same value to exist. So anyways, that's a good example where we build the index, but it also creates a unique constraint that makes it so not more than one can exist. And there's different types of constraints. You can set a not null constraint to mean that, hey, it can't be empty, right? Like maybe we don't let people create user accounts without an email address. That would be a not null constraint. We don't let people have a transaction that doesn't have a transaction amount. That would be a not null constraint. You can also do a check constraint where maybe we're talking about a yes or no, like, hey, we're recording survey responses. The response has to be either yes or no, and we could build a check constraint to where it can't be maybe, it either has to be a yes or a no, for example. You can index multiple columns together. One thing I forgot to mention. So for example, like this full name, if we're talking about students, maybe we don't want to index just first name and just last name, but maybe we want to index the two together because that creates more uniqueness. Not necessarily uniqueness, but we're never going to search for just last name. We're never going to search for just first name. We're going to search for both at the same time. So you can do multiple. Okay. So this is really what I wanted to get to, the different types of indexes, because each one has its useful case, and there's times you want to use one and not the other. So anyways, we have a B tree index, and then we have a bitmap index, and then we have text indexes. And text indexes are like largely kind of more what we're used to thinking about, but we'll talk about these others. So B tree indexes is kind of the default, and this is kind of like what we've been talking about with titles of books and that sort of thing, where basically the way the computer segments it is it lumps things into bins, and then it knows and it organizes these things into bins, just like our filing cabinet. Again, if you think about that, if you know exactly which drawer to go to, you go from 1 million records to 10, and that's kind of just the idea, is that it kind of gives the computer a path to kind of get to a specific place. Anyways, and the idea is that this one tries to keep everything balanced. So it tries to keep equal groupings, just like we would in a filing cabinet. Like if we were trying to use the least amount of drawers possible and have them filled up to maximum efficiency, you're going to kind of balance it out. And some bins may have more letters than others based on the volume. But again, this is where that work comes in, because every time we're adding records, it's going to constantly try to keep that balanced. All right. So, and then we have this bitmap index. And so anyways, there's a B tree indexes are great for those things like where, we have a lot of like for example, book titles in a library. There's tons of different options. But they don't work as good if you think about like let's say we wanted to sort it based on, like, let's just use fiction or nonfiction, right? Two groupings. Obviously, the B tree index doesn't work well for that because there's only two options to begin with. So narrowing that down doesn't do much. It only cuts it in half. Like let's say you're 50-50. It doesn't do any good to cut it in half because it's not isolating down to a limited set. And so anyways, this is where bitmaps come in. So bitmaps are a lot faster for when you have kind of more categorical, fewer options, that sort of thing. So like state would be a great use of bitmap versus a B tree. And then text indexes are huge. I really wouldn't worry too much about it. This is like if you're storing like large chunks of text, not like just like a title, so to speak. But like, let's say that you were storing the description of a book, right? Like the description, and you were looking for like a certain word in the book description. That's when the text index would come in handy. All right. So that's that. Anyway, so we're going to talk a little bit about how we can show kind of like the the results of this. Then let's use a real example here to kind of finish off. Maybe. Oh, and that's why I need to start it. All right. Let me turn on my SQL here real quick. All right. So now go back here. All right, let's use Sequila. You know, I'm actually going to use, well, let's try this. So I'm going to say select everything from customer. There we go. And what we're going to do is we're going to look for a specific email address. And I'm just going to kind of pick one of these at random. All right. All right. So we can run that. And yeah, so we'll try a little bit here to see what's going on here. So there shouldn't be, I don't know if I have an index on here yet or not. So I'm going to say create unique index, and we get to name it unique one customer. And I'm going to say on customer email. All right. And it looks like I do have it. So let's do, we're going to just go here so we can see the indexes on here. So here's my, that one's not unique. This one is, so I have two of these. You can see both of these here. And what's cool is in MySQL, you can actually see this one's a B tree. That one's also a B tree. So I'm going to drop both of these real quick, and then we'll just create the one. Drop index customer Q1. Do I have that customer one? Yeah. There we go. All right. So now what we're going to do is I'm going to run this one, and I'm going to see, I've never actually tried this in Workbench. So we're going to see how our mileage varies here, but I'm going to use this called explain. We're going to run this, and we can see here, this kind of explains what happened with the query. So you can see here, and we'll keep this here. I guess just note here, you can see it says filtered 10 rows 599. Type all, and you'll notice on keys it says none. That kind of thing. So now what we're going to do is we're going to create this index. And then I'm going to run this again. And now you'll notice that the rows is 1. It filtered 100% essentially. And now you'll notice that it used the key. And so basically, this is kind of just explaining how much faster it is, so to speak. If that makes sense. So if you ever have like a big query, what's nice is you can kind of evaluate the performance of it based on whether there's a key, or if you run a query, you can see, oh, is this using any keys? And there's one other way we can do it. Let's see if it's in here. So we have the explain. Extra constraints. Index results. All right. Yeah, we'll just leave it at that. So it doesn't cover the other ones. Okay, perfect. Great. Constraints, etc. All right. Yeah, I think that about does it. And like I said, the exercise this week are really just more about like building things and that sort of thing. So not anything super tricky this week or anything I feel worth going over. But does anyone have any questions about indexes and constraints? All right. Well, if no one has any questions, we will leave it there. If something comes up throughout the week, let me know. Otherwise, hope you guys have a great week.